All right, let's dive into a family of viruses that, believe it or not, most of us have probably had, but almost no one's ever heard of. They're called enteroviruses. They are super common, incredibly complex, and, well, they're hiding a pretty big secret. So, let me just start with this question. What if a virus's name was basically lying to you about what it does? I know, it sounds a little strange, but that's the big paradox we're going to unravel today. And the answer lies right here, with the enterovirus family. See, that prefix entero, it literally means related to the intestine, the gut. And that part is true. That's their home base, their primary site of infection. But here's the twist. They almost never cause any gut problems. No, their impact is felt all over the body. So they live in the gut, but they do their real damage somewhere else entirely. Now, think of this family as having two main branches. On one side, you've got the one everyone knows, the notorious polioviruses, infamous for causing paralysis. But on the other side, you have literally hundreds of its non-polio cousins, common viruses like Coxsackie that cause a whole bunch of other illnesses, from just a simple fever to some pretty gnarly rashes. Okay, so to really get a handle on this family, we have to start with its most famous or infamous member. Let's dig into the story of polio. It's a true public health epic full of devastation and, thankfully, an incredible scientific triumph. For a huge part of the 20th century, this was the terrifying reality of polio. It was a disease that sparked widespread fear, causing paralysis that mostly affected children and changed countless lives forever. The stakes could not have been higher. So how in the world does this even happen? How does a so-called gut virus end up causing paralysis? This illustration kind of shows the journey. The virus doesn't stay put, it travels. So let's break that pathway down. The invasion basically follows 4 key steps. First, it gets in, usually through contaminated food or water. Second, it sets up shop in the throat and intestines and just starts multiplying like crazy. Third, and this is the absolute key, it breaks out into the bloodstream. That phase is called viremia. And finally, in a small, unlucky percentage of cases, it makes the jump into the central nervous system. And that is where the real danger is. This is a look at exactly what happens once it gets inside the central nervous system. The poliovirus is nasty. It specifically hunts down and destroys motor neurons. Those are the cells in your spinal cord that tell your muscles what to do. When those neurons die, the muscles they control just stop working, which results in what we call flaccid paralysis. But here's something that might totally surprise you. For all its terrifying reputation, paralysis is actually an incredibly rare outcome. Just look at this chart. For the vast majority of people, 72%, there are 0 symptoms. None. Another 24% just get a minor kind of flu-like illness. It's only in less than 1% of all cases that the virus actually leads to paralytic polio. Okay, now let's look at a different number, a much, much more hopeful one, greater than 99%. What on earth could this possibly represent in the story of such a devastating disease? That number, it represents one of the single greatest public health achievements in all of human history. Since 1988, global vaccination efforts have wiped out more than 99% of all wild poliovirus cases around the world. It is an absolutely unbelievable success story. And this isn't just some abstract global stat. Let's look at a real-world example to see what it looks like on the ground. This timeline from Sri Lanka shows the whole journey. You see the major epidemics back in the 60s and 70s with hundreds of cases. Then the last confirmed case in 1993. And finally, being declared polio-free. It's a perfect blueprint for what's possible. So the fact that we've nearly eradicated polio it's monumental. But that doesn't mean the enterovirus family itself is gone. Not at all. In fact, with the biggest threat now contained, what we're left with are its hundreds of much more common, but thankfully much less dangerous cousins. These are the enteroviruses you or your kids are way more likely to actually run into today. First up, herpangina. Yeah, the name sounds a little scary, I'll give you that, but it's a really common childhood illness. It's caused by the Coxsackie virus, and its signature move is these painful, little blister-like sores that show up in the back of the mouth and throat. And this is exactly what that looks like. You can see those really distinct white ulcers with the red borders right there on the soft palate. Super uncomfortable for sure, but a classic telltale sign of this specific non-polio enterovirus getting to work. Next up is another celebrity from that Coxsackie A virus group, hand, foot, and mouth disease, or HFMD. The name pretty much gives it away, right? It causes a rash or little blisters, typically on, you guessed it, the hands, the soles of the feet, and inside the mouth. And here you can see that classic presentation perfectly. On the left, you've got the vesicles on the palm, and on the right, a similar rash on the feet. For a lot of parents out there, this is a very familiar sight. It's just another way this family of gut viruses makes its presence known far, far away from the intestines. Okay, so we've been focused on these viruses that hang out in the gut but cause trouble somewhere else. Now, to really hammer home the enterovirus paradox, let's bring in a different kind of gut virus for comparison, one that actually acts like a gut virus. Everybody meet rotavirus. Looking at it under a microscope, you can totally see how it got its name. Rota is Latin for wheel because of this distinct shape. And unlike enteroviruses, rotavirus is a true gut pathogen. It is a major cause of severe diarrhea and vomiting, especially in little kids. It infects the gut and it causes major gut symptoms. Simple as that. This table really puts it all together beautifully. Just look at the comparison. Both non-polio enteroviruses and rotavirus call the gut their home. That's their primary site. But after that, their paths couldn't be more different. Enteroviruses jump into the bloodstream to cause rashes or meningitis elsewhere, while rotavirus just stays put, damaging the intestinal lining directly. And that's what causes all the diarrhea and vomiting. So, we've got these different viruses with totally different game plans. The big question is, how do we protect ourselves? Let's take a look at our defenses and how they're perfectly tailored to each specific threat. Our defenses are really twofold. For a super severe but very specific threat like polio, we developed an amazing high-tech solution, a vaccine that is incredibly effective. But for that huge, diverse group of common non-polio enteroviruses and rotaviruses, well, the best defense is timeless and simple. Good old-fashioned hygiene. Washing your hands, that's the key. And let's just come back to this powerful image one last time. It's such a stark reminder of what's at stake, but it's also a powerful symbol of what we can achieve. This sight, once a common and terrifying fear, has been nearly wiped off the face of the earth, all thanks to focused, scientific, public health action. You know, the story of these viruses, and especially the story of polio, it's not just about disease, it's about solutions. It shows us a blueprint, a roadmap for how to tackle enormous public health challenges, which really just leaves us with one final question to think about. What will our next great success be? Thanks for joining me.